Alright, I have finished building this model and the terrain and the outbuildings and the other pieces, the ones I thought were necessary to be shown to address what we're going to be trying to do with this. I've also sized the members, the beam it's going to take to come across here, and looked at what the impact of coming out a certain distance is going to have, and how that situates itself on your land. And following that, we will be having to address, not in this film, but we'll be having to address issues with regard to the deck and this shed, whether that stays in its existing location or gets rotated or moved a little bit. We will have to decide going forward. First, though, to talk about this beam and opening this up and what it's going to take to come across there with some sort of a beam that's a clear span of around 25 feet. And actually, when it's done, it's either going to be 3 20-inch LVLs or a W10 by 39 steel beam. But this is how the floor framing, I assume, must be done, with the existing steel beam back here buried in that wall, and these lookout for the cantilevers on each end, on both ends. And this red is the last band joist, or the end joist, the band joist down at the south end. I want to show it to you here. This is how I calculated the load, assuming there's a center bearing wall that comes down to that steel beam. And I came up with about 710 pounds per lineal feet. And I ran this particular beam, the new beam, using load reaction linking, so it just does it automatically. And their solutions were either the 3 20-inch LVLs, and you can see 4 18s, but 3 20s, or a 10 by 39 steel beam, I-beam. And that bears out, they had 8391 on each end. That comes to about 650 pounds per foot. I also checked this with the book, with the Weyerhaeuser Microlam book, and they were also indicating kind of 320s. We're so on the line here, I guess, that the program automatically said 320s if we use LVLs. Now, the problem with LVLs, you'll see this is the existing framing here, a section through that looking west. And I think this wall is just a 2x4. I don't know why this wall is 10 inches thick, but it should be closer to 9. I don't know if there's a big gap here or what. But this is the floor joist, the 2x10s coming over, and this is that end joist, that band joist, that red one. Now if we use, right there, the red one, and then if we use these are 3 20-inch LVLs shown here, and you can see they project down in here about 10 inches or so, maybe even 11. But this is probably doable. This is doable where these plies are all nailed together, and then but that would have to be removed. I don't think they'll let us mount this to the outside of that like that. I don't think it'd be very reliable. We have all the roof load that comes right here, and all this floor load comes here. It'll all kind of be just hanging on that. So really, if you want to use the LVLs, I almost think you've got to pull them all the way in under that wall. Get rid of this band joist and cut these off. At least cut them off. Well, at least get rid of the band joist. That much is, you could probably get by with doing that. They're fastened together right. But I'd prefer to see it like that if it's going to be LVLs. Now, if you use the steel beam, though, here's those LVLs. You have about 7 foot underneath. Once they're covered in drywall, you have about 7 feet underneath them, and about 11 inches comes down. And it's very similar to the steel beam. It also comes down 11 inches, and it's a bit wider. This is, I think, is close to 8 inches wide once it's clad in drywall, and it is about 11 inches projecting down into the room. So aesthetically, they're about similar. Now I like this. This is probably simpler to do once you get someone there to put the beam in. But this, once this beam's prepped, this is probably easier to do than cutting this off, because when you mount that up there, all the way up there like that, you have to cut off the nails that are holding this plate down. It's really kind of a rigmarole. So I kind of recommend that you use this steel beam. And if you do use the steel beam, then this, we have 9'8" from in this nook here back beside the closet. There's 9'8" up to that steel beam, the clad steel beam, and then the 9" it's about 9 inches wide. And so I kind of called out, okay, well, if we're going to have this big beam down here, I guess we should have it in the center of this space. This was just starting points, you know. So we have 9'8" on this side of the beam, then up to that closet wall, and 9'8" on this side. And maybe one of those windows is reused on that wall there. So starting from this floor plan here, in these dimensions, and then adding that same 9'8" on the other side of that beam. Now that is a little bit almost wider. You had talked about 10 as 8 foot or 10 foot. But because of this beam not being able to be flush, it can probably be made flush, but it would be some rigmarole, and probably have to have an engineer, but it could be mounted up into that wall, probably a couple 20s, but it'll be a real pain in the neck. So I did this for now, and came out 9'8", and so this does make this a big room, though. It's, you know, it's 20 feet here and 20, almost 26 here, so it's a huge room. But I don't know how else we can justify that beam, and it could be that we could run additional ceiling work, if that, maybe that, where there's some additional lighter beams coming through here, drywalled also and painted. But for now, this is just, I wanted you to see how the size of this was going to, how the terrain was going to impact this, and etc. So I just started with this 9'8" depth, and then when we take this elevation 24 looking up this way, this section through here, this is the same height as your room, 94.5 finished, okay, and here's the trusses. And these trusses have to have an energy heel down here. They have to have at least 10 inches down here for the required insulation. So those had to go that much just to start with. Now those are 412 to match the rest of the house, but even dropping these to 312 does not completely solve this window issue. I've got that pretty accurately located. And so if we do drop it to 312, you do have to put ice and water shield on the entire roof, because of the shingles aren't warranted underneath that, under 412, and that's the code under 412. And additionally, you can see here, you will have to move that window over a foot or shorten it up or something like that. And I mentioned in a text, I don't know how this room, how this is divided up here, whether that lends itself to being an oddball or not. But that's one thing that's considering. But starting from that, then I left these roof pitches at 312 because we could get away with it without moving that window just a foot, like that. And then as far as the patio cover, that's this part down here kind of roughed in, the same width, because we're going to just use that same roof plane over all of them. But I'm showing, 16.3 inside there. There's going to be a column here. I'm showing 16.3 inside there. I think, frankly, and just ignore the fact I've got doors up here right now. We were thinking that cooking would be up here and some other things, but I'm not sure 16.3 is even enough. But I wanted you to see how that much shaped up on the land, 16.3 foot depth. And for now, just ignore the colors and textures. I was just working with the mass for now. And this is that 16'3" patio, and really the columns, all this is just put in here very quickly to show you where we are and where this is going with this. This is about 4'3" here, 4'3" here, and 4 foot here. So we have to do something with that, obviously. And of course we're going to have a fireplace at this south wall as well. And so starting from something like this and ignoring, I haven't done any work with the deck or this shed. It's just seeing what this structure was going to be like. But we go from this to this with that 16'3" from here to about the back side of these columns. And from this, that same structure added on like that. And ignore what's happening up here. This all needs to be discussed and hashed out. Now this does have a flat ceiling. I do show us stepping down just to get this lower down into the grade, so I have you coming down 2 stairs into this room, and that because this ceiling is all the same inside and outside, so that gives you about a 9'2" height out here, with this patio sloping out here, picking up another couple inches as it slopes. And where I was saying it was 4 feet is here, it's about 4'3" here. This is the existing land, pretty close to the existing land. It's got to be within 3 or 4 inches of what you have out there. This foundation wall is not showing, but that's okay. And then I believe I just was messing around with some of these stone textures. You have to look through some catalogs and see where I think that if we end up with this big of a chimney, which is going to be pretty big just because it's a wood-burning fireplace, and I don't even know if that's going to be done in stone, but if it is going to be done in stone, that's probably where the color design should start. Now, I just picked this stone here because it was good enough for now. I adjusted this brick a little bit like this, I guess, to get, I don't know, it seems like this is closer to what you actually have out there. And this was just some siding that I began with to try to see what the impact was going to be. This is what they call taupe. I'm not sure which way you were leaning, and there's quite a few more variations than this. I was just trying to get something to harmonize with this brick and this stone for now, just to see what the impact is. And because I couldn't really be positive what you're looking for exactly, I started with something like this. And I don't know, maybe those corners should be the same color, or maybe all that trim goes to this cream or some consistent color. But that was just as far as I got with just, I wanted a quick look at how the siding, how that helps the structure as well. And then for now there's just a couple of final things. I noticed on your sketch you showed a pathway coming down here, so that will need to be accommodated. You can see that the way this comes down, it's hitting here before it's even level, so I'm not sure how we want to address that. And then I don't know about that shed either. I think that the footing, I think that's going to be completely rebuilt, that bottom portion, including the footing. And if it is, whether we consider shifting that to be less at odds with the house, and maybe we're able to make some sort of more gracious thing to go up here to this area here, without there being such an encroachment there. I know there's a big tree back here somewhere, but that is one of the things we have to also consider and probably take a look at. And then the final thing, I mentioned this at the right at the start, that I thought we were going to have issues with this setback line. This is the 15-foot setback line, and so if we're starting to get there, I actually think this will probably come out another couple feet, but we really start getting on the line here. And I don't know if they're going to give us a headache, but I'd like to run this by them and find this out. This is that plot plan, and you could see, I mean, I think you were already non-conforming. Almost, yeah, I mean, you were already out over that setback line here, and obviously your neighbor was completely over it. So I think it'd be fairly easy for them to approve this, but I couldn't say that for sure. But it's probably one of the next steps as soon as we decide, as soon as we have enough depth with this. That should be the next thing to decide. And then this is just a quick look at that inside room with that big beam. And then following this, a silent film. So thanks, and I'm sure we'll talk.